Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video, we'll discuss question number 16. Hello students, in this video, we'll discuss question number 11, NEET Physics paper 2016. So let us start question number 11. Students, let us start the question number 11, which is on potentiometer. A potentiometer wire is 100 centimeter long and a constant potential difference is maintained. So let us consider a potentiometer. This is the setup, and here supposing that this is a potentiometer wire. This potentiometer wire is 100 centimeter long. This is the length of this potentiometer wire AB, which is 100 centimeter, and a constant potential difference is maintained across it. So if current I is flowing, then this if I is constant, then the potential difference is also constant. Two cells are connected in series first to support one another, and then in opposite directions. So I have got two cells, E1 say, and another cell, that is E2. They are first connected in series, so I connect them in series as E1 and E2. Plus minus means it is supporting each other in series. This is the right connection. This is positive terminal of the driving auxiliary cell, and this is also the positive terminal. Plus minus, and then it goes over to the galvanometer and a point somewhere here, and where the current to the galvanometer becomes 0. Two cells are connected first in series to support one another. This is called series connection and supporting each other, and then in opposite direction, then in that case you have to reverse the direction of the battery. The balancing points are obtained at 50 centimeter and 10 centimeter from positive end of the terminal. The positive end, so this is 50 centimeter from the positive end of the wire in two cases. The ratio of EMF is, firstly, we must know that if I have a connection like this, E1 plus E2 means they are supporting each other. In this situation, I'll think that I have the battery of EMF E1 plus E2. I can think of, imagine of a single battery of EMF E1 plus E2. So I know that if I connect and balance, I get a balancing point, then the first balancing length that I will get is E1 plus E2 if any cell E is balanced with and then is proportional to L, and that E is equal to some constant to L. This is the concept that we are going to use. E1 plus E2 is a potential gradient into the length, suppose that is L1, where it is balanced. Similarly, for the second case, when this oppose each other, the battery has to be connected like this, plus minus plus. So this is E1 minus E2 or E2 minus E1, whichever is greater. I take the magnitude of that. So that is how it is done. So this also is supposing that E1 greater than E2, then the difference is balanced at some another balancing length L2 over there. Because this, if this is balanced with this length L1, supposing that this length is L1, where this is balanced, then the potential difference created across these 2 points must be equal to this, because there is no internal resistance. I will consider only the because the current is not flowing. Even if there is internal resistance, the potential drop will remain equal to the EMF of the battery, which is E1 plus E2. And here across this, suppose the voltage drop is V1, and that V1 is equal to this E1 plus E2, which is measured by KL1. Therefore, I get E1 plus E2 scale 1. Similarly, I will get E1 minus E2 scale 2. Obviously, this is dropping, so this will be less than that. L1 and L2 are the balancing lengths are two different situations, and these balancing points are given by 50 centimeter and 10 centimeter respectively. So that means this L1 is 50 centimeter and this L2 is given as 10 centimeter. And we have to find the ratio of the EMFs of two cells. Our aim is to find E1 over E2. Because E1 and E2 both are unknown and we have to find that. If I divide these two equations, I'll get E1 plus E2 over E1 minus E2 equals to KL1 over KL2. K will cancel out and this is the equation I'm getting. If I use componendo and dividendo, I know that E1 plus E2, that is A plus B, so E1 minus E2 divided by E1 plus E2 minus E1 minus E2, that means E1 plus E2. Because componendo dividendo is A by B equals to C by D, then I can write this as A plus B by A minus B is also equal to C plus D by C minus D. This is called componendo dividendo. I can think of this as A, this as B, and this as C and D. A over B, I can write A plus B. So if I plus this, then E1 and E2 will add up and E2 will cancel out. Similarly, so doing that, I am getting L1 plus L2 over L1 minus L2. So from here, this will cancel, from here, this will cancel. This is 2E2, 2E1 over 2E2, which is sum of the balancing lengths divided by the difference of the balancing lengths. This 2 will cancel out. I am getting E1 over E2 as the sum of the lengths divided by the difference of the lengths. If I put those values here, I'll get the answer. If I put those values, I know that this is E1 by E2, sum of the lengths, that is 50 plus 10, that is 60 centimeter, divided by 50 minus 10, that is 40 centimeter. That will cancel out, is the ratio, no unit, 60 over 40, which is 0, 0 cancel, 2 3s are 2, 4s are 2, 2s are 4. So E1 over E2 comes out to be 3 over 2, which is the option number 1. So option number 1 is the right answer, 3:2. 3:2. Okay, thank you.